Hi, everybody. This is your screencast on the scientific revolution. The last time I talked about slides was for the Protestant Reformation, and I left off with the effects of the Protestant Reformation. And one of those effects was that people started to question the Catholic Church, especially Martin Luther with his 95 Theses. And they thought, well, if the church was wrong about indulgences and so many things that they claimed were in the Bible, what else is the church wrong about? And what else have we been believing, not just in terms of religion, for so long that may not actually be true? And so in the 1500s, the scientific revolution started, which is a change in thinking and a challenge to the ancient thinkers and the Catholic Church and what they had always told people. All right, so your definition of scientific revolution is a change. This is a change in the way people thought. And they began to question the world based on their careful observation and in challenge to existing beliefs. So, really, the heart of the scientific revolution has to do with people's beliefs about the universe. And for thousands of years, the church had supported what is called the geocentric model. Geo means earth, right? So, geocentric, earth centered model. And this model was put together by Aristotle in ancient Greece thousands of years before. And basically, it stated that the earth was not moving, that it was the center of the universe, and that the moon, sun, planets, everything else in our solar system was revolving around us. Because if you observe the sky from Earth, you see that, right? Stars move across the sky, the sun moves across the sky, and we cannot feel ourselves moving on the earth as it moves. So, to someone observing with the naked eye, the geocentric model made sense, and that's why the Catholic Church supported it. So, in the early 1500s, there was a Polish astronomer named Nicholas Copernicus, and he was studying under the church. He was a church cleric, and he was studying the geocentric model, and there were some problems with it that he noticed and that he pointed out. For example, if you chart the path of the planets, sometimes they appear to go backwards and then forwards again. So, sort of crossing their own path in their orbit around the Earth, if that's what you were believing, that the Earth was the center. So he suggested that the Earth was not the center of the universe and that the sun was the center of the universe, and this became known as the heliocentric model. Okay. I might have taken out the slide about Copernicus, but obviously stating that the sun is the center of the earth, the universe, and not the earth is going to go against what the church has always told people and supported. And so Copernicus waited until he was on his deathbed to publish a book with his ideas in it. The problem for Copernicus is that he could not prove his theory was true because the technology did not exist. So, about 100 years later, not even, in Holland, they developed the telescope. And in Italy, Galileo Galilei built his own telescope to see if he could prove that Copernicus's model was true. And so basically, he charted the path of the sun and the stars and the planets, and was able to prove that indeed the sun is the center of the universe and the earth revolves around it, just like all the other planets and stars. Okay, so his theory will support Copernicus's theory, right, in the heliocentric model and go against the teachings of Aristotle from ancient Greece and the teachings of the Catholic Church. So, the church, obviously, now having the proof against them that they were wrong, called Galileo into a church court, much like you saw if you watched the scenes from the Martin Luther movie and saw the court that Martin Luther was called before. Galileo Galilei was called before a very similar court and asked to recant or take back his statements. The Pope angrily summoned Galileo to Rome to stand trial before the Inquisition. Under threat of torture, he knelt before the cardinals and read aloud a signed confession agreeing that the ideas of Copernicus were false. So, unlike Martin Luther, Galileo did recant or take back his statements, but he lived under house arrest and died in 1642 near Florence, Italy. And it was not until 1992 that the Catholic Church officially acknowledged that Galileo was right and that the sun is the center of the universe. Okay. So one of the things that Galileo used to prove that the heliocentric model was correct is called the scientific method. And you may have heard of this or even used it in some of your science labs, right? It's a step-by-step process in order to test a hypothesis, gather data, and answer a question. Okay, a logical procedure for gathering and testing ideas. Whoops. All right. So here are your steps to the scientific methods. First, you ask your question. What is it that you want to find out? So in Galileo's case, he would have asked, is the sun the center of the universe? And then you state your hypothesis. So he would have stated, I believe that the sun is the center of the universe. Then you conduct an experiment. For Galileo, he would have been charting the paths of anything he could trace with his telescope in the sky, most importantly, the planets and the stars. Then you analyze the results and you make a conclusion. Either you have proved your hypothesis is true, or you've proved that it's not true. And in that case, you need to come up with a new question and start the process over again. Okay, so now we move into some of the other scientists and mathematicians who use the scientific method to discover new laws in math and science. The first one is Rene Descartes, and he was a scientist who said that older scientists need to reject the old assumptions and teaching. He didn't rely as much on experimentation, but more on math and logic. And he said that everything should be doubted until proven by reason. So his name, Rene Descartes, is just one that is associated with the scientific revolution. All right, Isaac Newton, you've probably heard of before. Discovered the force of gravity. He said all objects are affected by the same force. Every object in the universe attracts every other object, and that attraction is gravity. And that the degree of attraction depends on the mass of the objects and the distance between them. So one thing that Aristotle's model of the universe did kind of account for, I guess you would say, is that there are these spheres that each celestial body, the planets, the stars, are in that keep them close to the Earth. Whether it's the Earth or the sun that's the center, it is true that there is this force that keeps us, right, the Earth and all the planets and stars revolving around the sun, and that force keeping us close is gravity. So Isaac Newton came up with the laws of gravity. Okay, some scientific instruments. The microscope, first invented in 1590 by a Dutch maker of eyeglasses. And obviously, this is going to be used to do scientific experiments so that we can see things that we wouldn't be able to see with the naked eye. A barometer was invented in 1643 by one of Galileo's students himself. And the thermometer in 1714 was invented by a German physicist, used to show, obviously, the temperature of things, but more importantly, that water freezes at 32 degrees. Uh, oh, this chart is right. They're talking about Fahrenheit versus Celsius, right? Freezes at 32 degrees Fahrenheit or 0 degrees Celsius. Okay. And so that's it, guys. Moving forward in the 1500s into the 1600s, it's a real time of change in the way people thought, a time of challenging and questioning, especially what the Catholic Church said. Eventually, we're going to talk about the Enlightenment. A lot of questions on the Regents exam, and you could be asked on your Regents exam at the end of next year, depending, about the scientific revolution, and they relate it to the Enlightenment, which we will get to after our Age of Exploration and after our absolute rulers. The Enlightenment was a movement in challenging government and the way government works and the way rulers work and who gives rulers their power. And so first comes the scientific revolution, followed by the Enlightenment. But just in general, it's a real time for questioning and challenging existing beliefs using experimentation and observation. And there's a hint for one of your questions. Don't forget to do the castle learning. Thanks so much, guys. I miss you.